Imagine being able to create any material you want. You can dream it and you can make it. By simply changing out a few atoms, a few bonds, you can make it do whatever you want. That's the beauty of polymer science. I'm Austin Evans, a 2021 Schmidt Science Fellow. I've pivoted from synthetic chemistry to applied physics, and I'm now an assistant professor at the University of Florida, working on the future of plastics. All plastics that you see in your everyday life are polymers. Polymers are everything around you. They're your clothes, they're your paints, they're your adhesive. They've influenced every facet of human life. Chemists have spent a lot of time learning how to form the molecular bonds that hold polymeric materials together. But one thing we haven't been able to do is to control their larger structure at will. As a Schmidt Science Fellow, my interest is figuring out how do you push polymeric materials into things that they don't already do. To make polymers that are electrically conductive or do more exotic things, that is much more challenging. If you look in nature, everything is a polymer as well, pretty much. The trunks of trees, that's a biosynthetic polymer. If you think about like the scales on the belly of an alligator, they have this nano texture that make them very hydrodynamic in the water. Whereas if you think about like the unstructured polymers we have in our kayak, you don't have that nanostructure, and so they're not as hydrodynamic. I think the question is, if nature has exploited soft materials forever to engineer all sorts of unique functions, like, can we do that as synthetic chemists? And I think the answer is yes. I think I really connected with the natural world early on. I'm originally from Oklahoma. We would raise butterflies in our kitchen and tadpoles. And my grandfather was a botanist and worked for NASA to learn how to grow plants in space. And that's like a pretty amazing thing to think that humanity can do that. Seeing his lab as a kid was just so exciting. Science is such a daunting challenge. You don't have someone you can look to and say, answering a big question like that is possible. The best part is that I get to pay that forward and help develop the next generation of scientists. The demonstration that we have this large issue with waste plastics is an indication that these materials are incredibly valuable. What we have to think about is how can we get those desirable qualities into materials that are easily recycled or that just naturally break down when they've reached the end of their function. Nature develops incredibly strong materials that are built out of biodegradable chemistries. I think that as synthetic chemists learn to exercise that higher level of control, we're going to be able to match biology in that way. There's applications we haven't even fully dreamed of yet. You could start to imagine devices that might prevent seizures. You could imagine being able to control your cell phone with your mind. Like, the possibilities become pretty close to science fiction pretty fast.